blood to itself. So just as the heart is going to supply blood to the body, it also has to supply blood to itself. The heart is an enormous muscle, and it requires a tremendous amount of cardiac output in order to just carry out its normal functions. So, because of that, the heart actually has its own system of arteries. So, as you can see, the coronary arteries actually branch off the aorta right above the aortic valve. Here's the aortic valve, and here is where the coronary arteries actually branch off. The right coronary artery, or RCA, and the left coronary artery, or left main coronary artery, or LMCA, branch off directly from the aorta itself. From there, they each have smaller branches to supply the front and back side of the heart. On the right side, you have the right posterior descending artery, which wraps around the back, and the right marginal artery, which wraps around the front. On the left, we have the left anterior descending artery, or LAD, that supplies the front left side of the heart, and the left circumflex artery, often written as LCX, which wraps around the back left side of the heart. You can kind of see it shadowed right here. Now you notice there's more branches on the left side, and that's because it's much larger than the right side. It's a larger muscle than the right side of the heart, so it has more vessels on that left side. Now the main vessels that are susceptible to blockage are going to be your RCA, your right coronary artery, your LMCA, the LAD, and the LCX. Now, we're going to learn more about the blockage and how this all works in the myocardial infarction lesson. On the left side of the heart, these vessels are actually supplying blood to the left atrium, the left ventricle, and part of the septum. The right side of the heart is going to supply blood to the right atrium, the right ventricle, part of the septum, and also the SA and AV nodes. Now, the SA and the AV nodes are responsible for electrical activity in the heart, so you can just imagine that if someone had a blockage on the right side of the coronary perfusion, they might be susceptible to arrhythmias. Now, one more thing that's important to note about how and when the heart perfuses itself. So, let's say we have our heart here, and we have the aorta coming out of the heart, right on this left side of the heart. Remember how I said that the coronary circulation branches right above the aortic valve? Now, if you think about systole and diastole, the heart contracts in systole and the aortic valve opens, okay, during systole. Now, when it does open, this valve opens, it's going to momentarily block coronary circulation. We have our left and our right. So as that valve opens, it's going to momentarily block these valves and stop blood from flowing to the heart itself. Now, then the heart's going to relax during diastole. So this valve is going to close, and those vessels will not be blocked any longer. So when that aortic valve closes and these vessels are no longer blocked, blood can actually flow to the coronary circulation. Now, there's also a pause right after diastole to allow filling of the ventricles, and this gives even more time for blood to flow to the coronary arteries. So the heart perfuses the body during systole, and it perfuses itself during diastole. So during systole, that's when the body gets perfused. During diastole, that's when the heart is actually being perfused. Now it's time to do a little bit of critical thinking. Now, so if my patient's heart is beating extremely fast, okay, let's say we got an extremely fast heartbeat going on here. What happens to the time in diastole? It's going to decrease drastically, okay? So instead of lub-dub, pause, lub dub, pause, lub dub, pause. It becomes lub dub, lub dub, lub dub, lub dub with no pauses in between. Okay, so the EKG is going to be really fast, and there's not going to be any time for pause here. So where we would normally have this pause and these intervals here, that's being cut down. And what do you think's happening to this patient? So if my heart perfuses during diastole, during this rest time, what happens to coronary perfusion in severe or prolonged tachycardia? It's going to decrease drastically. Okay. Now, think about it. It's like pressing a water fountain. Let's say you have kind of a water fountain here, and you got your little button. It's like pressing a water fountain over and over and over, and this water just keeps shooting out. And expecting to get a full drink of water, it's just not possible. You have to hold it down and allow the water to flow. Okay. So without that diastolic pause, the heart struggles to ever really perfuse itself and get this blood that it needs. These will just be opening and closing, never allowing enough time for the heart to actually perfuse itself. Now, in the ICU, when we see a patient in significant tachycardia, like for example, like SVT or supraventricular tachycardia, like in the 160s, okay? So if we ever see like SVT in the 160s, who's stable, what we all do is we all kind of look at each other and we say something like, well, that can't last forever. The heart is eventually going to just give out because we know that the patient's coronary perfusion is decreased significantly. This heart is not getting the oxygen that it needs, the nutrients that it needs to continue to work as hard as it's working. So that's just something that I want you to keep in mind, that I want you to be aware of. If you have a patient who's severely tachycardic for a long time, you will know how important it is to address the situation. So remember, the coronary circulation is how the blood gets to the heart muscle itself. So coronary circulation is blood getting to the heart itself. Both sides of the heart have a main coronary artery, and then that branches to cover the whole muscle. Okay. The heart perfuses the body during systole, but it perfuses the heart during diastole. Now, lastly, prolonged tachycardia can lead to decreased coronary perfusion and even myocardial infarction. So I hope you guys learned something today about coronary circulation and what that means and how it works. Now, I want you guys to go out and be your best self today.